Hey guys, just wanted to do a quick follow-up video to my last one. I know in my last KS0 overclocking video, I went into more depth on how to actually do the modifications that you need to device, whether that's tearing it down, replacing out the thermal paste, putting on the VRM coolers, then also putting the shrouds in the PSU that I recommend for it. All that stuff is recommended modifications for it, and honestly, at the end of the video, I'm going to go over the temperatures that we found on the VRMs. And it's almost going to be required to do any kind of overclocking on the KS0 Pro. So in this video, I'm going to mostly go over any of the questions that I got asked a lot in DMs or in the Discord or YouTube, and also give you kind of a better step-by-step guide on how to actually go about overclocking your KS0 Pro. And by the way, this applies to all versions actually, KS0, KS0 Pro 1 and 2, and I believe the 3, because that has voltage control. The named variants or the lettered variants of the KS3 do not have voltage control, so all you'd be doing is following along for the clock. So anyways, where we're going to start is, people ask all the time, what is a good starting point for the KS0 Pro? In all honesty, there's a lot of silicon lottery kind of going on with these. So honestly, I've seen a lot of people try 125 megahertz. That's what I've tried, and it seems to be stable at no millivolts added. So I'd say anyone that has a unmodified KS0 Pro, about 125 megahertz on top of the base clock should be pretty achievable with no voltage offset. But remember, every time that we add more load onto it, your wattage is going to go up. I believe we saw 115 watts at the wall on a stock KS0 Pro with the stock PSU at 125 megahertz. So you are riding the limit already of that power supply. And like I said, later on in the video, we'll go over the VRM temperatures that we found. It will be actually coming in a later update for the KS0 and KS0 Pro. You really do need to do the cooling mods to the VRM on this. It's really bad. So anyways, you can see that I applied a little bit of an overclock earlier. I stepped it off to record this real quick. Just wanted to make sure everything was going to work. So as you can see, another thing I got asked is, how does it step up? So what the board does is every 30 seconds, or the firmware does every 30 seconds, it will bump up 25 megahash or megahertz. Every time you see it step up here, that's it going up. And then over here, I got asked a couple times, hey, why does the voltage go down? This is called V-droop. V-droop happens in all electronics that are under load, especially any kind of circuits, like an ASIC or a GPU, a CPU for that matter. Anytime you add load, the voltage will drop, and so it's getting pulled down. So every time we push the clock up, the voltage on the chips are going to drop. People say, okay, well, do I need to add millivolts immediately to bump it back up to where it was sitting at 420? No. Most of these will just run the way they are. They'll drop down. There was some that had it all the way down to 400 millivolts on their average, and it was still running. Doesn't mean yours is going to do that. You're the judge of it. Just watch your hash rate and see if it's fluctuating a ton. Speaking of, what is a good gauge for your hash rate? It's not the 5-minute, it's not the 30, it's the 2-hour. Honestly, the 5-minute, it goes up and down constantly due to variable difficulty, the pool's adjusting for your hash rate, all kinds of stuff. So your best bet is to look at the 2-hour mark and look to see if you are getting any kind of rejects in the pool. I do know that PBFarmer has a whole solo stratum deal that you can set up on your local node, that you can set a static difficulty on, and that might help give a better idea of where your actual hash rate is. I haven't really tested it out personally yet. It's just an idea. But with the current firmware the way it is now, your best bet is to watch your 2-hour average to see if it's holding out. And then I got asked this: if I apply an overclock, how much hash should I be looking for to get back? It should be 1-to-1. If you push it 25% faster, you should see a 25% increase in hash rate. If you do not see a 25% increase in hash rate, it means that it's unstable and you need to add voltage. How do we go about adding voltage? So the KS0 Pro, compared to the other versions, has a much more fine tune to it. You can go up 2 millivolts at a time on the KS0 Pro, compared to the KS0, KS1, and KS2. Those ones require 6 to 7 millivolts every time you step it up. So that is something to keep in mind. You can get pretty nitty gritty with this miner. So I know for a fact on mine, to achieve a 300 gigahash overclock, I do need to put in around 32 to 36 millivolts in order to keep it stable there. Another question I got asked in the chat a lot was, what is a safe amount of voltage to go in? To be completely transparent with you guys, nobody knows right now. The assumption is that it's like the other ASIC chiplets, that 500 millivolts is the limit. Problem is who really wants to push the machine to the point of failure, because there doesn't seem to be any kind of hard limit on the device itself. At least when PBFarmer is pouring through the machine code, there is not an actual shutoff on this device for temperature or for voltage or amperage. There's no current or voltage protection. I think there might be a temperature protection on the ASIC chiplets. There is not one on the MOSFETs, even though there can be. So keep that in mind. I recommend going if you see that it's unstable, your clock's dropping off, or your mega or your gigahash is nowhere near where it's supposed to be. Go ahead and bump it up 2 to 4 millivolts at a time so you see it start evening out. And then that's basically it. I would say increase your megahertz clock 25 at a time and watch for stability. Does it take a long time? Yes. Does it give you a more consistent overclock that runs colder? 1000%. Your device is going to run colder if you do it that way. Your device is going to run more efficiently if you do it that way, rather than throwing a massive amount of voltage at it and just sending it to the moon. Like I said, I would personally keep the millivolts below 440 millivolts. I do know that on other people's firmware, that's what they put in as their canned value is 440 millivolts, and they were pushing them all the way up. I think the TS one was up to 360 gigahash. Problem with that is not all devices are that way. Like I said, for example, mine, after I do that kind of 36 millivolts, will tend to sit at 430 millivolts total when I'm at 320 gigahash. So that's 10 millivolts below. It tends to run a couple degrees colder then too, which is obviously going to increase the longevity of the device. So that is the point of this tuning software, is that it gives you way more finite control over everything, and therefore you can tune your clocks to be the way you want and your temperatures to be. Speaking of temperatures, so that was the thing that I wanted to bring up. So PBFarmer went and poured through a couple devices, including my own, and we believe that he's found the VRM temperature. We're pretty confident it's the VRM temperature. It's what it should be reporting back, at least for where it was in the code. What we saw was that at stock, let me pull up the numbers real quick. At stock ambient, on an unmodified KS0 Pro, running 200 gigahash, the MOSFETs were sitting at 90 degrees C. And then with a 25% overclock, they were sitting at over 100 degrees C. I believe that he said they were pushing up into the 110 range, 115. Is that within spec for the MOSFETs on the device? Technically, yes. If we go off of what it says online on the engineering specifications, it should be 150 degrees is your maximum non-sustained temperature. 125 is your sustained temperature. Does that mean you should keep it at that temperature? No. But it does tell you where the upper limit is. It also shows you that it takes very little to actually get it up to a temperature that's above 100 C. And that's without any millivolts added on top of the stock box. That's just increasing clock speed only. On the modified one, so we did online, just to give you guys the numbers on it, the intake temperature was 25 C, the exhaust temperature was 37 C. At stock clock, the MOSFETs were running at 45 degrees Celsius. Like I said, do the modifications, because clearly it gave us a ton of thermal headroom. And at 25% OC, I'll give you guys a little sneak peek right here. At a 25% OC, we are getting 100. So it says 125. What this is you actually deduct that from, or 75 from that. We are sitting at 50C currently. So this will be added later on. It looks like we're going up a little bit here. This will be added later on into the actual UI. You'll be able to actually see all that information. I find it to be a good indication also of stability, just another tool in your tool belt. If your VRM's temperatures are not fluctuating more than 3 or 5 degrees C, that's a good indicator that your clock is stable. If it's going up and down like 10 or 15 degrees, you gotta think of it as your chiplets are putting a load on it and that's increasing the temperature, then they can't keep up. So they're dropping off or downclocking, and that's dropping the load and therefore dropping the temperature. So what I have found is watching that and making sure that my VRMs are sitting within about 3 to 5 degrees between updates is a pretty good indication of stability. So that will be coming in an upcoming update for the KS0 Pro. I believe you said 1, 2, and not on the 3s currently. So that will be only for the 0 through the 2. Hopefully sometime in this week, we'll see. That's up to him on his release schedule on it, along with a couple other updates like quality of life things, making so there's a dark mode for all this. Alright, so we're going to go ahead and give this a little refresh real quick. See where we're at. You can see I'm getting 267 gigahash on the pool side, sitting at 230. Like I said, wait for the 2-hour mark, but it does seem like it's running very, very, very stable at this speed. So only one rejected so far. Our exhaust temp is going up, and our VRMs are still sitting at the same temperature. So I hope you guys found this video more helpful. Honestly, huge shout out to you guys. I did in the last video put my my eBay and my Etsy store up for all the stuff that I print. I do make the shrouds for these devices. I am working on designs actually for the other ones too. I do kind of need to get measurements for the KS1, 2, and 3 in order to start designing those ones out and doing the work for it. But huge shout out to you guys for picking those all up. I actually ended up having to buy a new 3D printer because I couldn't keep up with you guys. And plus my other printer took a crap on me because I was pushing it so hard. So huge shout out to you guys for that one. I'm definitely going to be releasing something probably next week when the update comes out for the VRM plus the other quality of life stuff. Yeah, if you ever have any questions, feel free to leave a comment down below. Shoot me a DM or at me over in the kaspa Discord. It's the same as my user on here, Lukewarm IQ. Oh, someone was memeing about doing immersion cooling on these and seeing what the upper limit of it is. I know it's a stretch, but if we hit, I'd say, I don't know if I want to say 1 or 2. Let's say 1,000 subs on here. I will go ahead and get a Tupperware. I have 4 240mm radiators and a fish pump, and I will go and throw my KS0 Pro in it and run some immersion cooling and maybe do a live stream of putting it in there and overclocking it, just to see what the upper limit is and go to the point of, I'd say maybe go to the point of failure or until we see that we actually hit a upper voltage limit or a temperature limit. So thank you guys for all your time. Like I said, if you have any questions, feel free to comment down below. Peace out.